Lean Six Sigma process improvement relies on data, and we analyze data using statistics. Statistics can be hard to master, and if you don't have an engineering or scientific background, that could be even harder. However, I believe that anyone can learn to interpret the results. And in this video, we will review data types, probability, and key statistical concepts. Let the software do the hard work and crunch the numbers, and I will teach you how to interpret the results. So statistic is the science of collecting and analyzing the data, making inferences and interpreting results. There are two branches of statistics, descriptive and inferential. Descriptive statistics describes or summarizes features from a collection of information. Inferential statistics analyzes sample data and makes inferences about the data. For example, analyze sample of population and make inferences about median hourly wage of a population. Data types: quantitative discrete, like 1, 2, 3, etc., and quantitative continuous, like 1.3 or 2.5. And there is qualitative data type, the type of data that can only be categorized like sex, male or female, yes, no, good, bad, great. Qualitative nominal is a type of data that cannot be ordered, for example, colors, red, blue, yellow. And there's qualitative ordinal. Those can be ordered. An example is like such: great, good, bad. Probability is simply how likely something to happen. Probability is always a number between 0 and 1, or 0 and 100%. Probability could be described by many functions, for example, the most famous normal distribution or uniform distribution. Normal distribution is very popular and used in many applications, and is also known as bell curve. So let's talk about the normal distribution. It has several interesting characteristics. For example, the rule 6895 99.7, and it tells us that 1 sigma represents 68% of the data, 2 sigma represents 95% of data, and then 3 sigma represents 99.7% of data. Mean is average of a data set. Usually mean is denoted by Greek letter mu. Standard deviation describes dispersion of data. Small standard deviation means small dispersion of data. When standard deviation is increasing, the bell curve is stretching. Shapes of the distributions. The shapes are normal, skewed to the right, or skewed to the left, and bimodal. Bimodal meaning two peaks. So when we're talking about a distribution, there are important concepts that describe the distribution: mean, median, and mode. And 3 more: standard deviation, skewness, and kurtosis. Let's look at median and mean. Mean is just an average of data, and median is a middle number in ordered data set. An example of calculating mean: just sum up all the numbers and divide by the count of numbers in the data set, and you'll get the mean. In this example, mean is 45 divided by 9, or equal to 5. The median is the number in the middle of the ordered set. Here's the middle number is also 5. And if the number of elements is even, then you just simply add up those two numbers and divide by 2. Mode in statistics is the most frequent number in the data set. For example, if you have a data set that is on the screen, then you can clearly see that the most common number or most frequent number is 4. Range is simply the range of data, and in this example, the range is from 1 to 5. Normal distribution has a skew of 0. However, when distribution is not perfect, then we'll use skewness to evaluate how much it is skewed to the left or to the right. Kurtosis is another measure of normal distribution imperfection. Kurtosis tells us if the curve is not bell, but more skinny or too fat. Normal standard distribution has kurtosis of 3. Standard deviation is calculated by this formula, but don't bother to memorize it. We'll use Excel to calculate it in the future and only learn how to interpret that. Variance is just simply standard deviation squared. The standard error is a statistical term that measures the accuracy with which a sample distribution represents a population by using standard deviation. Sigma is measure of variance in data. And don't worry about memorizing these formulas or definitions. We will use Excel to calculate descriptive statistics and interpret the results. So next we will talk about intuition for